So in the past, almost all equipment manufacturers used hydraulic cylinders for providing linear motion. And for good reason too. It's a low-cost way to move mass around. However, there are encumbrances involved in this technology, such as leaky hydraulic systems, fairly poor positioning and velocity control, and finicky feedback devices, because you have to use a linear feedback device such as an LTD. And moving in today's world, equipment is largely PLC based, with most motion control provided by electric servo motors. So this has sort of spoiled us engineers into the controllability of electric servo motors, and then when we kind of revisit hydraulic cylinders, they seem comparatively antiquated in terms of their controllability. So Exlar Corporation, a Minnesota-based company, identified this kind of contrast of technologies, and they created a product called a roller screw actuator. And a roller screw actuator offers engineers the performance, the physical performance value of a hydraulic cylinder, such as force, speed, and life, with the controllability of an electric servo motor. So let's dive into this technology and see what exactly it offers engineers, and more importantly, how it works. So what does a roller screw actuator offer your application? The physical performance of a hydraulic cylinder, such as forces as great as 40,000 pounds, speeds as fast as 40 inches per second, and very long life expectancy. Now, the other major offering is the controllability of an electric servo motor, because this is in fact an electric servo motor driven mechanism. And you can achieve an infinite number of positions and achieve very great speed control. So this demonstration is designed to illustrate that, and here I've got an Exlar Tritex. So this product is a little bit different than their bread and butter product by the fact that it's got a servo amplifier and controller mounted to it, which make it exceptionally good for retrofit applications where you don't want to build a new control cabinet housing servo drives. So I can provide it just an analog input and choose positions and velocities based on that. So here you can see just how controllable it is and how quiet it is, which is another benefit to electromechanical systems. If you compare it to a fluid-powered system, which has to have a hydraulic pump, or if it's pneumatic it has to have an air compressor, those can be very loud, even at rest. And with an electromechanical system, you can hear it's silent when it's not moving, and when it is, very quiet. So now that we've illustrated the controllability of the product, let's take a deeper look into the guts of it to understand how a roller screw works and how Exlar employs it into an electromechanical actuator. So at the heart of every roller screw actuator is a roller screw mechanism. And here it is right here. So I've got this black tube and I've got this rod. And in between the rod and the tube are a series of planetaire rollers. And they provide the interface between the two devices as to minimize the friction and also transfer the rotational motion into linear motion. So you can see as I spin the tube, the rod will advance. Okay, and I can decouple these quickly, and now you can see them more closely. The tube is threaded on the inside, as we said, and the rod has a series of planetaire rollers attached to it, which happen to be cogged. So there's never any sliding between the roller interface and the rod, or the roller interface and the tube. So now that we know how the mechanism works, let's see how Exlar employs it into one of their actuators. So now that we're looking at the guts of the Exlar actuator, let's talk about two key design features that enable some unique possibilities. Now the first is that Exlar has the motor in parallel with the mechanism, meaning they've got magnets attached to the tube and a copper winding stator wrapped around that. That's unique because it decreases the total length of the actuator when compared to a ball screw or an Acme nut style, which would have a motor hanging off the back, somewhere to about my hand here. Now, the second unique feature is that they can place nearly anybody's feedback type on the back of the mechanism. So you can have an absolute or incremental encoder or even resolver that is selected to work with a specific servo manufacturer's drive. So to briefly recap, roller screw technology offers the physical performance of fluid-powered actuators coupled with the controllability of electric servo motors. So after watching this video, you may have an idea of your own how you could implement one of these actuators to improve your process. And if that's the case, reach out to Exlar Corporation and they'll help evaluate your application to determine which actuator product best suits it. So thanks for watching, guys. We'll see you next time.